Hey, Aloha Friday. Welcome to Stan the Energy Man. I'm Stan Osterman from the Hawaii Center for Advanced Transportation Technologies. And we're here today all out of breath because my guest and I have spent all morning at Joint Base Pearl Harbor Hickam dedicating her gigantic, gargantuan piece of blue machinery that takes rubbish and turns it into electricity, heat, and all kind of good things. So welcome to the show. We have as a guest today Renee Comly from BESSI, Biomass Energy Systems Incorporated. They're a worldwide company that's based out of Chicago with offices in New Jersey, and they do stuff all over the world, turning rubbish, waste into all kind of energy products. So welcome, Renee. Good to have you on the show. Finally, I think I've been trying to get you on the show for a couple months, and we finally got a hold of you.
I know, I've managed to elude you a little bit, but thanks for having me on the show, Stan. I really appreciate it.
Well, tell us a little bit about how you got into doing what you're doing, because, you know, a nice New Jersey girl, how do you get into...
How do you get in the waste business,
how do you get
really?
into the rubbish business?
Well, it's fairly straightforward. I was more or less a marketing person working in environmental programs, and I wound up working with a variety of engineering companies that were doing new types of technologies for the harbor, New York and New Jersey port. And I worked with 5 different companies that had technologies and actually worked with them on Bond Act money. So it was my first exposure in how public funds and how research money can advance new technologies. I have a keen interest in the environment. I like to fish, you know that. And I've always had an interest in making things better and making sense of things. And in New Jersey, we have, of course, a reputation as a big state with waste. Mm-hmm. We send it to other people. And we are also, you know, the garden state. Mm-hmm. And so we've got a lot of areas where you can't put things that are polluting or even seen as polluting. And I got interested in doing waste to energy, which in our case is gasification, through some of the inventors that I worked with originally. Mm. And I wound up working with folks out in Chicago, and I found that there is an extensive pool of PhDs out there that do extraordinary things all the time. So I thought it would be a good idea to team up with a couple of them and start bringing things out to out into the real world. And that's how I started.
Okay. Well, it's kind of a big leap, though, going from something that you're just interested in, that you have a passion for, into a business that's the size of your business that has projects in India and South America and Central America, and you buy equipment in Germany and all over the place. I mean, how did you go from being just kind of sort of interested in energy stuff to being a worldwide, you know, corporation?
Well, it started out, I actually started about 20 years ago. And this company started in 2007. That's when I founded the company. So it has been a long time. And during the course of it...
So you started when you were like 12 or 13 years old?
Yes. Actually, I was a child prodigy in the environmental field. And the way that it played out was essentially what we started doing was looking at how the research world was interfacing with the more practical side of waste management. And in the US, there weren't a lot of opportunities for us to take a new technology and get it into the field. So we started working on DOE projects initially, and we're fairly unsuccessful because the DOE projects were looking more for a track record, which is great, but it's also, it sort of left out some of the newer things that didn't have the volume of information behind them. Right. So this was brand new without anything behind it. So we had to kind of make our own way. Okay. So we teamed up with a variety of different companies. One of the companies was Unitel out of Chicago. Great group of people, brothers. A lot of cursing in that office, very interesting. But we learned a lot working with them, and they've been extremely successful. Fielding technologies, I think the principal there has 300 patents in different types of things, from waste to energy to DME. Really fascinating group. So starting out and working with them really gave us a good foundation, and that helped us start our first plant, which was actually in Korea.
Okay.
So most companies start out with a small-scale plant. We happened to be fortunate enough to find a client who wanted a 100-ton-a-day plant. And in our terms, the one that's here in Hawaii is 10 tons a day. So this was actually 10 times the size, and that was the one we started with. And it was very successful. Unfortunately, it didn't work out on the business end for our client, because they actually sold the land that the facility was on. It was an industrial park. So, but it was a great lesson. So the team that we have here in Hawaii today actually has experience running a 100-ton-a-day system.
Right, and we've had Alex on the show before. So he how long has he worked for you then? Was he around for the Korea project?
Yes.
Okay.
And Alex, how long has he worked for me? I don't even know.
Okay. More than a couple years.
Yeah. Alex is an integral part of everything BESSI does.
Okay.
And we have other companies together where we've done commercial work, because BESSI, Biomass Energy Systems, has been, generally speaking, we've done government work.
Okay.
And what we've tried to do is limit some of our involvement to the new and developing things. So when we get to the point where we're actually selling equipment and doing a design, build, own, operate, that'll be under W2E, which is our other company. That's our commercial company.
Okay. Yeah, so when we talk scale, and ours is 10 tons a day at Joint Base Pearl Harbor Hickam, but when we talk scale, even at 100 tons a day, that's a fairly small system on a municipal level. Because I know H-Power here is 3,000 tons a day capacity.
Right.
And they're running 2,000 tons a day through it right now, incinerating and making electricity for Hawaiian Electric. But your system is kind of in that lower end of the spectrum of getting rid of waste and turning it into ash. I kind of want to say burning it, but it's not really burning it, so that's why I get stuck for words. Running it through a pyrolysis gasification type system, turning it into ash and usable synthetic gas in your system. So I know Alex explained, but what I've learned is some of us take 2 or 3 times to be trained. Explain to us a little bit about the gasification process, especially related to your equipment.
Well, the reference for H-Power, as an incinerator, there's probably only about 50 of them in the U.S., and they're all large scale. Those incinerators were built over the last 20 years. There haven't been new ones recently. H-Power has added to their volume.
Okay.
So they're one of the bigger incinerators around. Essentially, what gasification does is similar in results to incinerators. In other words, you put waste in, you get power out. The difference is the conversion process that takes place. In an incinerator, you're direct firing, so you're burning things, just like you would in a fireplace. What we do is we convert the material, so we're causing reactions within a reactor vessel. Ours is a fairly primitive vessel. It's a rotary kiln, which the world has a lot of experience with rotary kilns, which is why we use it. And in using the rotary kiln, we're taking the material and we're able to process it and also see what's going on as we're processing it. So we can do shift on the fly of conditions inside our reactor vessel, which makes us a bit different than other gasifiers, but it also gives us the ability to process material you wouldn't necessarily put in an incinerator. So you wouldn't direct fire, like tires. Okay. Tires have a high BTU value. They're like putting coal into something like this. So when we process something like that, we're turning it into a gas. We're then taking the gas and cleaning it to as clean or cleaner than natural gas, and then burning it. So our emissions are only on the engine. So the gasifier doesn't have the kind of emissions you would have at an incineration process.
Okay.
So the scale of it is, the incinerators are great for doing the giant waste burning, because they have all kinds of controls on their flue gas. But for what we do, we're taking things they don't. So that's generally a smaller volume.
Okay.
So from the perspective of what we've been looking at, and to use the MSW, the municipal solid waste type of example, when you take municipal solid waste or a recycling feedstock, the material comes in and you can separate out things that can go to be recycled and reused.
Right.
So in doing that, you're reducing the volume. and the volume of material that's left generally goes to a landfill. And that landfill material is what we process.
Okay.
So by taking that, we do basically a net zero solution. So we're the pickup. We take all the stuff that's left over, and we make it into power. And
then what goes to the landfill is a lot smaller.
Yeah.
It's inert, basically, and so it doesn't harm the environment.
Right.
And the volume is reduced greatly, so it doesn't take up as much space, so your landfill
lasts
can last longer.
Right. And also, we're looking at that for adding to cement mixtures.
Okay.
That kind of ash.
Okay.
Yeah, we understand Hawaii has some paving opportunities.
Yeah, we have lots of paving opportunities. We have so many paving opportunities, my car's screaming for paving opportunities.
That's what I'm hearing. That's what I'm hearing. You don't have snow. What is going on?
I know. We don't have salt on our roads all that good stuff. Well, we're coming up on a break here. We're going to take a short break, and we'll be back in a few seconds with Renee Comly from BESSI and talk about what she's doing here in Hawaii.
We talk about why people should like science, why science is actually fun, how science is a dynamic and vital part of everyone's life, why everyone, every man, woman, and child on the planet should really know science, should love science, should be familiar with science. So it's a great show. People come on here and have interesting conversations with us. They tell us why they do what they do, why they love it, why we should love it too. I hope you'll join us every Friday, 1 to 2 p.m. And of course, you can see it anytime on YouTube. Aloha.
Hey, welcome back to my lunch hour. Stan the Energy Man here with Renee Comly from BESSI. And today's show is BESSI Meets West. Because she's from the East and we're from the West. So I was as creative as I could get on short notice. But we're going to talk a little bit about what's going on out at Hickam Air Force Base. Right now, BESSI has a project with HCAT, my organization, and we're putting together some waste to energy and photovoltaics and other renewables, some wind in creative ways, and we're going to show the Air Force how to use renewables on their base to reduce the amount of energy that they have to import, and eventually, hopefully in a deployed location, how they could survive without convoying fuel and things like that into their site. So we have some photos here of BESSI's equipment going up. We'll throw them up on the screen. This is more like the one you did in Chicago, right? The scale.
Right. This is the 2-ton-a-day system that we built as a demonstrator unit. And you see the platforms that are underneath. Those are actually the bottom of the shipping containers that we integrated this into. So essentially, this is the bare bones. These are the equipment pieces, but all the wiring and piping that goes in between them was actually installed inside the containers so that it was very compact as far as it could be moved easily. It wasn't meant to be a forward operating base system, but it was meant to show that we could operate at a very small scale and produce net power, which it did.
Which is a challenge for this kind of a
big
technology.
challenge.
Okay, so it looks like it fits in like 4 or 5 containers, 5 containers. And so you could roll it onto C-17s if the military wanted and take a 2-ton-a-day system someplace.
Sure.
Did this thing make electricity or hot water or?
This system made electricity. It used a Caterpillar engine. It was a dual fuel system that we used, a diesel engine, and we had great success with it. The only thing was, at this scale, and this is a completely independent system, so it was not connected to anything at all.
Right.
We actually installed everything into the containers, moved the containers out into a field. So it was about an hour outside of Chicago. And during the sub-zero temperatures they had a couple of years ago, we ran.
Okay.
So my engineers, who are from all over the world in some very warm climates, got a sense of what Chicago winters can be like. So that was educational for everyone. But the system itself performed very well. We were pleased with the results. And essentially what they had us run, it was for the U.S. Air Force Research Laboratory, and what they had us do was run wood. And the idea there is when you do any kind of gasification, everything works on wood. It's a fairly straightforward kind of control material.
Right.
So we ran on wood and it was great. But we didn't have the contract to run more. So when we got back and said, okay, what do you want us to do next? They said, we'd like you to try some more different materials, but what would you do with this system? And we said, well, we'd like to reconfigure it. So what we're doing right now, this particular system, we've taken completely out of all of those containers, and we've skid mounted everything.
Okay.
So it sits in our new location in University Park, Illinois. We'll be adding pieces to it. Okay, so this is, we have a new set of engines for this, which is the same as the engines you have
Okay,
here.
they're custom built.
They're custom built, they're gas engines, so they're different than the diesel. And the way that will operate, it's laid out in a line, so it's very simple. You can stand on our mezzanine and actually see it. It looks like a museum.
Okay.
And when it's completed, we'll have all the different pieces so that you can evaluate the performance of each piece, and we can add new things. So we're very flexible as far as feed, and we're very flexible as far as output of energy products. So those are the things we're going to be testing over the next 2
Okay.
years.
And this looks like it has a shredder and a hopper. So,
It's
what was
completely turnkey.
Right, what was the net output of energy or power from this particular unit, 2-ton-a-day unit?
This engine was a 120 kilowatt engine.
Okay.
And we reached the max output on it. We also had a couple of different situations where our gas overwhelmed the control systems because it's an off-the-shelf piece of equipment. We weren't allowed to really mess with their programming.
Right.
So we had great results, but we didn't want to use that kind of engine again.
Thus, you design your own engines for this.
So we
Okay.
designed our own engines.
All right.
Yeah.
And next shot is actually the system I think we're started here, and that shows it in its containers.
Yes.
So
yes.
the satellite dishes aren't part of your equipment, but
No, but they look nice.
that's
They're-
how it
yeah.
showed up here in Hawaii. So again, your equipment has the ability to be containerized and move fairly easily. So I wouldn't call it deployable from a military perspective, but certainly you could containerize it and ship it to any location and set it up at a facility that has maybe an acre of space to work out of.
That's true. That's true. The way that this was designed and the way the other one was designed, so each one of them had their own set of parameters. And essentially, we have the ability to take the core system and design all of the elements around it. So when we get a sense of what the client needs, so if it's 10 tons a day or it's 50 tons a day, we start with the core system and then we design around it. And if the Air Force said to us, we want a forward operating base system and here are the criteria for it, we would design to that criteria. So
Okay.
these, while they fit the parameters to a degree, they weren't designed for that.
Okay.
They were designed specifically to be easy for us to put up here in Hawaii, in the system that you have, the HCAT system. And the one for Illinois was just so that they could move it.
Okay.
So we can do a lot as far as customization, but what we try to do, we keep the core as a very standard, and we keep the other elements as standard performance elements. So we know what the performance parameters are, and we can sometimes buy off-the-shelf equipment.
Great. Okay, the next photo, I think, is Alex and I, and that behind us is the rotary kiln.
There you go.
So that one is the 10-ton-a-day, and that's really kind of a neat picture because when you see it on the ground, it looks a lot different than when you see it up on the mounted on the scaffolding and everything.
You two
And
provide excellent scale.
Thank you. Yeah, that's what we're there for, is to provide scale for the photo. And the next shot, I think, is actually more of an assembled, there it is, the fully assembled piece of machinery in place. So why don't you talk to us about the system, where it starts and what everything is there?
Okay, so in the forefront, you see the tarps, which I believe we own all of the tarps
Yes.
in Hawaii now.
Probably, I think Home Depot declared a
Moratorium on Alex. So those systems are the shredding and the feed systems. So essentially, this is a turnkey system the same way the 2-ton-a-day was a turnkey system. So you've got the shredding system that can take a lot of different materials, as long as you can fit it through that little shredder hole, okay? We run it through the conveyor system and into the gasifier, the gasifier being the cylinder
on the upper left.
on the upper left. And if what you see, the very end of it to the left is actually a hood. So the gasifier itself is the tube to the right of that, but that hood and there's a hood on the other end of it as well, are very important pieces of the gasifier. What they do, and the way the gasifier is designed, you notice it tilts to the rear.
Right.
Okay.
It's slanted downhill a little bit.
Right, so there's a bit of an incline there, and that's part of the geometry of how this is designed to operate. So when we deliver these things, putting the system in alignment is very important.
Okay.
And the hoods that you see there are very important also because they have our proprietary seals in them. Rotary kilns can leak, and that's one of the drawbacks in using a vessel that is used for different things like cement and concrete. When they do those kind of cement plants or aggregate, they have a lot of leakage. It's part of what they do. It's accounted for. What we do is capture all the gas. So those seals that are in those hoods are proprietary and are very, very effective. So we don't have the leakage that you see in those places.
Oh, I see.
Okay, we also have a slight negative pressure inside,
Got
but
it.
it's not a pressure vessel, which is
Right.
also very important in gasification.
And then the center section, that big tall section, does what?
That is where the gas goes in and it gets dropped down, and what it does is it actually drops the heat, so the temperature of the gas, because you can't use, the kiln runs at 1800 degrees and you can't use 1800 degree gas in an engine. So what we're doing is we're dropping the temperature and we're dropping out the particulates that are in the gas. And when you have particulates in gas, that's one of the things that you have in flue gas. Okay, particulates are one of the bigger problems in pollution. You really don't want that escaping. So we actually drop out the particulates in several different places within those different frames that you see there.
Okay.
So then it comes to the bottom down there, those little things that look like chaise lounges.
Right?
To the right.
40-foot containers
With the little
apples at
bolsters on the ends,
Right.
yes. And those house our engines. There are 4 of them. They total 500 kilowatts. And the way that they operate, that gas goes in at the right temperature for those engines. We designed those specifically for this gas, which is a low BTU value gas. And what it does is it produces the energy to not only run the system, which is not connected to anything else on the base, as you know, okay? It's a standalone, but it makes net power at 300 kilowatts an hour. Between 200 and 300. I know you're
Thank you.
comfortable with the lower value too, so I'll just say, but the net output at 200 to 300 kilowatts is
Yeah.
significant at this small scale of 10 tons a day.
So when I look at this and I do my mental math, I go, my house uses about 22 kilowatt hours a day, and this thing can produce at least 200 kilowatts
An hour.
an hour. I mean, so it's at 200 times 24 is how many kilowatt hours per day it's producing. I'm not really good at mental math here, but that's enough to do a whole community, basically.
Yes.
So we're not looking at a piece of equipment that is just kicking out enough to run your campsite.
Right.
This is taking 10 tons of rubbish and turning it into a community's worth of electricity.
Yes, yes it is. And the idea with this was to scale it actually smaller than what the base could use.
Okay.
We found that the base had probably, after the material went to H-Power, which is the agreement that they have with the city and county, which is very typical. Their municipal solid waste goes to where everybody else's does. What we did here was we took the non-recurring wastes, such as the construction and demolition debris, and a variety of other materials that don't go to H-Power for different reasons, but go to a landfill. So this was built to take materials that had landfill as a destination. And that's
Okay.
what we were trying to make sure we could do some landfill avoidance.
So I know you and I have talked about it. What are some of the things you'd like to see this equipment do in the future to demonstrate for the Air Force?
Well, what we're doing right now, if we can connect to the microgrid, I think that would be a huge boost for the industry, because there's a significant microgrid industry out there right now, and having renewables like what you have out at the site that HCAT has, which are solar and wind, and the cutting edge stuff that you guys are doing, combined with us providing baseload, I think that's a primary driver for us, to try to get that as a demonstrated, here's what you can do with what we do. Next steps after that, we can take different materials in. We can also do different outputs out. So as far as taking the waste material, just any of the waste material, and making it into a biofuel, that's something we have a real interest in.
Okay.
I think the Air Force has an interest in it, and I think at this scale, it would be a great way to determine whether it's actually practical.
Okay. And I know while you've been out here, you've also talked to folks like Heidi Comly about maybe taking some off gases from your generators and turning them into other products. So
Right. Heidi's got some terrific bugs and fermentation things going on in her offices. I highly recommend a tour if you have the opportunity.
Okay.
But she's got hydrogen producing bugs. She's got other types of bugs that take in the CO2 and can make a tremendous amount of what we call proteins. So you could do, we have power purchase agreements generally as part of what an output would be from waste to energy. With Heidi, we'd also have a protein purchase agreement where we could actually sell the protein material to farmers, which is kind of a neat thing that, for some places would be absolutely perfect, and for other places probably wouldn't. But
you could team up with Heidi, make hydrogen, and sell protein.
Yes.
All off of your turning waste into
out of
energy.
garbage.
All right.
Yeah.
That's the kind of stuff we like to do. I mean, it's that ecosystem. It's taking what was normally just let's burn it, and what can we really do with it to make it fit into an entire ecosystem. Well, we're going to take another quick break here, and we'll be right back with Renee Comly from BESSI.
Hi, I'm Chris Leatham, and I'd like to invite you to come and watch my show every Wednesday at 3. I'm interested in a variety of issues that have to do with politics and our local business economy. And I'd like to bring on guests who like to talk about everything from technology to social media to what we can be doing to improve our environment. And so I'd like to invite you every Wednesday at 3 to stay and watch my show here with Think Tech Hawaii. And I'll see you there.
Happy Aloha Friday, and welcome back to Stan the Energy Man on my lunch hour. And we got Renee Comly here talking about waste to energy and her gasification system out at Hickam Air Force Base. And it's quite appropriate that we got her at Hickam because she does like to fly airplanes. So why don't you go ahead and throw the next photo up. Renee there.
Remind me to kill you, Stan.
Sans makeup, so she's going to kill me. With a good friend of mine, Clint Churchill, and that's not just a little glider, that's actually a high-performance stunt airplane, and Renee wanted to go up and try that out. But
that was a lot of fun.
It's a pretty impressive airplane. But that's what Heidi does what Renee does in her spare time is come out here and do crazy things. Our next photo that we got coming up is actually a photo taken by Alex, her chief engineer out there, and it's a great shot. I think it's one of those one-of-a-kind shots that the moment comes along and you got to have a camera there. When they were assembling the equipment, there was this beautiful rainbow shot. So thanks to Alex, he's got your next Christmas card.
There you go. We call that the rainbow machine shot.
So Renee is all about unicorns and rainbows and making things great in our
Smart
world.
ass, Stan. Why am I here?
But back on subject.
Okay.
Your equipment is, we're doing great things with it, and we have great plans for it out at Joint Base Pearl Harbor Hickam. But tell us a little bit about your international customers and what they use your equipment for, and why your technology appeals to them. I know you told me a story about your Indian customers and how it affects the fact that they can't even do business until they start talking to somebody like you.
And that particular situation is a joint venture partner that we have in an area of India that is where textiles are produced. And in this part of the country, the major industry is dyeing and textile production. They take the waste material, a lot of which is polyester, and they direct burn it in incinerators. And this is an area that had been cleaned up 10 years ago. And now it's been polluted again by this burning of waste. And what our partner is doing is he's looking at what the industry needs. And there are 50 companies like his. And in his estimation, he said, if we could take that waste and gasify it, it's a great feed, it's polyester, it has a high BTU value, and he could use it to provide hazardous waste cleanup. The hazardous waste cleanup is stopping the rest of the industries from growing any further. The government regulations will not allow them to expand their operations any further until they deal with the waste. So this was a way for them to provide a sustainable cleanup for hazardous waste using a waste that they don't want burned anymore. So by gasifying that material, they're actually providing themselves with their own resource, their own fuel.
Yep.
So that's his particular expertise, and what he's looking for. He built a 10-ton-a-day system with us. He is looking to take that system and make it a research and development lab for all of India in gasification. So once he's done with what we're doing now, we're also building a 50-ton-a-day system for him, which will be a major piece of his plant. Then the 10-ton would become the research and development for India. And in a similar vein, another part of India has a recycling / landfilling operation where we have another client who has a tremendous amount of waste that comes in. And essentially, he's got 300 acres where they take every single thing that is valuable and they use it. So plastics get made into pipes. They have all sorts of different materials that they make into products, bricks and road materials. And they have these waste materials that are left over. And as I said before, we kind of back clean up. So that's what he's asking us to do, and it's a bigger plant. It's about 100 tons a day. So in his facility, we would be providing the net zero solution. So we've got two major things going on in India.
And what other countries are you doing business in?
Well, right now, we also have Puerto Rico,
Okay.
where we have a variety of different clients that have industrial footprints where they use a lot of power, and because of what's going on with the country, they're concerned that their power costs are going to go up.
Okay.
So looking at us and us providing them with this kind of gasification, they can take almost any kind of waste, so including tires, which they have quite a few, but between tires and municipal solid waste to power their own plants.
Great.
And that way they have a sustainable way of maintaining their operating budgets.
Okay. Well, here in Hawaii, I know you've talked to several people out here, other folks like Stephen Joseph at PVT Land,
yeah.
and Heidi Comly from up at Manoa at MIC. But I know you've also looked at actually fulfilling needs in our communities here in Hawaii. What are some of the things that you're looking at helping out to solve our problems here in Hawaii?
Well, Hawaii has so many Hawaii-specific issues, not the least of which is that it's an island. It's far away from other things. And the things that we're working on for the military have a lot of analogous situations to what the islands have. So what we've been looking at with Steve Joseph in particular, when we started working on the recipes for the demonstration we'll be running in the next month, he and I had talked about plastics, and he said, well, you want us to take the PVC pipe out? And I said, no, we want to run that. And he said, you're pretty much the only thing that we can do with that then. Sure, we'll make sure you have that in there. Those are the kinds of things that until you start working in the area, you don't necessarily find out that, oh, this is something they really need. Also, we're looking at the possibility of doing desalinization, which would take, basically it would be waste to water. Something that, Hawaii's got a very healthy water table, but it's the kind of thing that if we do it here, it's also wonderful for California to find out about.
Sure.
So Hawaii has a direct effect on many places in the Pacific.
Well, there are dry islands out in the Western Pacific that could use that technology as well.
Sure.
And we also talked about possibly some invasive species, or getting rid of the green waste from that can't be used for other things.
Well, there's two kinds of invasive species that we're looking at in Hawaii right now, and one in particular is the rhino beetle, which is an invasive species that is attacking which are the trees that you tell me about?
We have the
There's more than
kiawe
one.
trees
Right.
down in Hickam.
Right, and the palms.
Yeah, and the palms for sure. That's what it goes after.
Right, and so what we're trying to do is use those trees that have the beetle infestation and process them in the gasifier, because the alternative to that is using propane to burn them. So in our case, we're actually turning it around. So we're using that to make power as opposed to spending money to eradicate a species. What we're also looking at on the Big Island is during the last election, they had a huge hurricane. And the hurricane had such a devastating effect. And part of the reason that it did was because the albizia trees are right along the right-of-ways and the roadways. So they took down power lines and they closed roads.
Right.
So by looking at that particular species, which grows, I believe, an inch a day.
They're pretty, they're like weeds.
Yeah.
They're tree-sized weeds.
Yeah, and taking those and incorporating them into a feedstock and saying, okay, it's the Big Island, what does the Big Island have that we could fit this into? The concept would be distributed generation. So they have transfer stations there. So we might set something up at a transfer station, take the albizia trees and make power.
Okay.
So the idea, though, I think that we've been really interested in is continuing to work with the military and take what we're doing at Hickam to the next step, maybe at the PTA on the Big Island, and doing it there as a large-scale forward operating base, because it wouldn't be connected to anything else except to bring power.
And get rid of albizia trees.
And get rid of albizia trees in a sustainable way where we can actually support the economics of it too.
Great. Well, Renee, believe it or not, that's 45 minutes that is blazed by in a
Wow.
heartbeat. I told you it'd be the fastest 45 minutes in your life. So we thank you for being on with us today, and we look forward to working with you more at Joint Base Pearl Harbor Hickam and with the state of Hawaii and our counties as you try and help them with some of their waste energy issues, that you can help turn a problem into a positive, making some electricity out of waste. So thanks for being here today, and we'll have you and Alex back to tag team next time, and you guys can put on your comedy act or whatever.
There you go.
And we'll probably get higher ratings with both of you.
Well, thank you, Stan. You've been a huge, huge benefit to us as we've tried to move these things forward. And if it wasn't for you, we wouldn't be where we are. So thank you.
Oh, thank you.
And thanks for having me on the show.
No, it's great to have you. So until next week, Stan the Energy Man. Next week, we're trying to get on Mr. Renee DeRosa. Renee Andre DeRosa over here for his second visit. Talk to him about what he's looking for in the future here in Hawaii. So until next Friday, Stan the Energy Man. Aloha.